Welcome to Chapter 10. In this chapter we're going to be talking about finding areas of different polygons. To start out with here, 10.1 talks about areas of parallelograms and triangles. To start out with, we're going to talk about a couple of theorems. We got theorem 10.1, area of a rectangle. The area of a rectangle is the product of its base and height. So we've got area is equal to base times height. Here we've got our base, here we got our height, multiply the two together to get the area. Very similarly, theorem 10.2, area of a parallelogram. The area of a parallelogram is the product of the base and the corresponding height. So we have the exact same equation for both a rectangle and a parallelogram. Now the only difference is we still have the base here, but here we look for our height. So the height is not just that outside length over here. And that's not going to be it. We have to have a height that is vertical from our base. By definition, a base of a parallelogram can be any one of its sides. The corresponding height is a segment perpendicular to the line containing that base, drawn from the side opposite of the base. So here we've got two different rectangles that have the same lengths. One, I have chosen 6 to be the base and 3 to be the height. And this other one, we've turned the rectangle on its side, and now 3 is the base and 6 is the height. Now this is the exact same triangle, but again, I have chosen a different side to be the base, and if I found the area of each, I would still get the same answer of 18. When we are finding the area of a parallelogram, again the formula is area is equal to base times height. Now in this first example, our base we are going to use as 10 because that is the bottom length. Now for the height, again, as I mentioned before, we don't want to use this outside length in a parallelogram. That's not what we want. We want to use the vertical length right here, the 8. So to find my area, I take my base times my height, and I get 80 square inches. For this second example, you'll notice that our dotted line is this way, and we were given 12. 12 is going to be our height. And that dotted line with the right angle attached to it usually is our sign that that is the height. Now the height always goes perpendicular to our base. So in this example, here's our base. Well, if this side length is 8 over here, in a parallelogram, the opposite side is also 8. So our base is going to be 8. To find our area, base times height, and we get 96 square millimeters. For our next example, we've got parallelogram ABDE, and we want to know the length of DF to the nearest tenth. So we're going to be looking to solve for H. Now how we're going to do this is we're going to use that formula that A is equal to base times height, because I can find the area of this parallelogram. I've got a base of 8 and a height of 3. So my area would be 8 times 3, which is 24. Now the nice thing about this theorem is that now any combination of base and height in this particular shape is going to give me an area of 24. So for example, if I wanted to use this as my base, this 4 over here, to take the height times that 4, I should get the same answer as I did when I took 8 times 3. So what multiplies together with 4 to get 24? 6. H is going to be 6. For this second example, we are asked to find the length of h, which is this distance right here. We're going to use the same basic thing we did on the previous example. So go ahead, find h, and then once you're done, you can go ahead and continue to see how you did. Okay, as you can see here, I used my base of 7.8 and the height of 6, multiplied those two together to get an area of 46.8. Now any combination of base and height in this particular parallelogram will multiply together to get 46.8. So now I've got this base of 6.5 down here. I know that that is the length because this opposite side here is 6.5, and opposite sides are congruent. I'm looking for this height h. Well, 6.5 times h should get me that 46.8. I divide both sides by 6.5, and I get my answer of 7.2. The next theorem we're going to talk about is 10.3, area of a triangle. The area of a triangle is half of the product of a base and the corresponding height. So we've got our formula right here. A is equal to 1/2 BH. In our example triangle over here, I've got our base down here, and the height is the vertical length from the base. It's not one of the other side lengths. Okay, it's going to be that height there. Just like with parallelograms, the base of a triangle can be any one of its three sides. It doesn't have to be a certain one. The corresponding height is the segment perpendicular to the base drawn to the opposite side of the triangle. So if I have three triangles here, and if I just label the sides as 1, 2, and 3, if I draw the triangle like this, my base is going to be 3, and my height is going to be here. If I were to rotate this triangle to look like this, where I've got 1, 2, 3, 1 becomes my height, and there's my h. One more time rotating it, I've got 2, 1, and 3. 2 is now my height, and 2 is now my base, sorry, and then my height would be the vertical distance up from 2. So any one of these three triangles would work for a triangle with side lengths 1, 2, and 3. And if I found the area of these, I would get the same answer because my h's would all be different. Few examples of finding area of a triangle. Once again, area formula, 1/2 base times height. So for an example A here, the way this is drawn, here's my base, here's my height. So with my base, I've got two different lengths. I've got 5 and I've got 8, so I'm going to add those two together. My height is going to be 6. So I'm going to take my area, which is 1/2, times my base, times my height. And when I multiply those together, I get 39, and I put in my square feet label. For my second example, the way this picture is drawn, here's my base of 7. Now, I'm not going to use this 2, because the 2 is just the dotted line there. It's an extension. Okay, I only want to use the actual base. My height is this vertical line here at 5.5. So once again, my area formula is 1/2 times my base times my height. And my answer is going to be 19.25 square inches. My final example, with a right triangle. And you notice we've got a right triangle here. This is kind of different than the other ones. The right triangle, I'm still going to use the 1/2 base times height, but my base and my height are the two legs that are connected by the 90-degree angle. So my base could be 9, my height could be 6. I would still use the 1/2 base times height formula, and my area would be 27 square yards. The last thing we're going to be doing in this section is finding the area of an irregular figure. And how we're going to do that is we're going to break the figure up into figures that we do know how to find the area of. For instance, in this first example, in A, they want to know the area of the figure consisting of a rectangle and a triangle. So what I would do is I would find the area of this rectangle first, then the area of this triangle, and then once I have those two areas, I can add them together. So first, with the rectangle. Area of a rectangle is base times height. My base is 12, my height is 5. So my area is 12 times 5, or 60 square centimeters. For the triangle, this is going to be my base. So again, I'm going to be looking for base and height. My formula for triangle is 1/2 base times height. I know this side length is 5 because the other side of the rectangle is 5. So my base is going to be 5. Now the other side I can find is this for my height. And how I can find that is I know the whole thing is 16 and the rectangle's only got a side length of 12. So this distance here is what's left over from the 12, which is 4. So my height is going to be 4. So my area is 1/2 times my base times my height. My area here is going to be 10 square centimeters. Then to find the area of the whole thing, I take the two areas that I have and I add them together. 60 plus 10 is going to be 70 square centimeters. Go ahead and find the area of the second one. Make sure to pause it before you do, and then when you've got an answer, go ahead and hit play, and we'll see how you did. Okay, so as you can see, this figure is made up of a parallelogram and a triangle. So to find the area of the whole thing, we take the area of the parallelogram and then the area of the triangle, and we add them together. So for the parallelogram, I chose a base of 40, which is this length here, and the height of 18, which is this length over there. Multiply them together and I get 720 square meters. For the area of a triangle, my base is 50, my height is 18. 1/2 50 times 18 gives me 450 square meters. Once I have those two, I add them together to get my area of 1170 square meters.